Hi friends, today I am going to discuss a problem on principle of superposition. This is a problem of a steel rod having a length of 4.5 meter long and 25 mm in diameter is loaded as shown in the figure. Find the change in length of the bar. Here given E is equals to 200 gigapascal. E means Young's modulus. If you see in the figure, this steel rod is divided into three parts, that is AB, BC and CD. And if you see loading of the steel rod is to the left corner, you can see 60 kilonewton, and in the B section 10 kilonewton, and at C point 20 kilonewton, and at the right end 50 kilonewton is there. Length is equally divided 1.5 meter, 1.5 meter, 1.5 meter. Before solving this problem, you should know how to use the units. For example, if the load is given in kilonewton, if the length is taken in meter, then what is the value stress we will get in Pascal or megapascal, that we need to know. If you see, this is a usage of units. In question, if we have taken diameter or length in mm and the load in newtons, then we will get area in mm square, because diameter we are taking in mm, that's why area we will get units mm square. Similarly, and Young's modulus, here we are taking area mm square and length mm. In Young's modulus E we will get in megapascal. Okay, and stress value we will get in megapascal and strain in mm, because we are taking diameter in mm. And another type of units are, if you take diameter or length in meters, then load in newton, area, here we have taken diameter in meter, that's why area we will get in meter square. And Young's modulus pascals, here length meter and load newton, that's why Young's modulus we need to take in pascals. So if you take Young's modulus in pascal, the resulted stress we will get in pascals. Okay, and strain in meters, because length we are taking in meters, so strain also we will get in meters. Okay, this is one kind of usage of units. In this problem I am following the first kind of units, that is length I will take in mm and load I will take in newtons, and finally we will get the change in length, that we will get in mm. Okay, and one more thing, here this is a steel rod. For steel, generally in question if steel Young's modulus is not given, we will take 200 gigapascal. Okay, if in question if they have given 210 gigapascal, then we need to take 210 gigapascal itself. Okay, 200 gigapascal means 200 into 10 to the power of 3 megapascal. Okay, that is 200 into 10 to the power of 9 pascals. Giga means 10 power 9. 1 gigapascal is 10 power 9 pascals. Mega means 10 power 6. 1 megapascal is 10 power 6 pascals. Okay, hope you understand how to usage of units. You have understand well. Okay, let's go into the problem. Okay, here they have given 25 mm in diameter. Okay, here area is same throughout the section. So first we will find area. Okay, area. We know for area, if the diameter is given, formula for area is pi by 4 d square. That is pi by 4, d value they have given, diameter in 25 mm. So 25 mm square, pi by 4 d square. Pi means 3.14 by 4 into 25 square. If you calculate this value, we will get 490.6 mm square. Okay, this is area. Area is 490.6 mm square. And one more thing, here loading they have shown in one figure. If we need to calculate separately, this is a part section 1, section 2 and section 3. Separately we need to calculate the change in length, and we need to add. Like if I differentiate the loading, this AB section, we can write AB section like this, and BC and CD, right? This is AB, this is BC, and this is CD. Okay, here 60 kilonewton is acting towards the left, So we need to draw 260 kilonewtons towards the left. Okay, and here if you see 10 kilonewton, here 60 I have drawn, that's why in B section also we need to draw 60. Okay, 60. And if you see in B, only 10 kilonewton is acting towards the left, but here I have drawn 60 acting towards the right. So in order to compensate, if I draw here 70, 60 is right, 70 is in left direction. So if you club these two, 10 towards the left, here 10 towards the left. Okay, that is matching here. Okay, if you draw 70 here, here also we need to draw 70. And if you see in section C, 20 kilonewton is towards right, but here I have drawn 70 towards right. So in order to compensate that, here I will draw 50 towards the left. If you see 50 left and 70 towards the right, so 20 towards the right is the resultant. Here 20 towards the right is the resultant matching. Here I have drawn 50, here also I will draw 50. Okay, here 50 and 50 is getting matched, 60 and 60 is getting matched, and if you see 70 towards the left, 60 towards the right, if you club these two, 10 should be towards the left. So 10 towards the left is matching. Okay, in this way we need to bifurcate the loading. Okay, this is a part 1, part 2, part 3. Part means part of the section. Okay, part of the length, L1, L2, L3. And here we need to find change in length of the bar. This is a bar. Complete change in length we need to find out. That is delta L of AD we need to find. A to D we need to find. Delta L AD is equals to delta L of AB plus delta L of BC plus delta L of CD. Okay, and we know that change in length formula is PL by AE. Okay, here P means load. Okay, 60 kilonewton, that is load, and L is length. 1.5 meters is there, this is the length, and A is area we have find out here, 490.6 mm square, and E is Young's modulus, that is 200 gigapascal. If you see this change in length of AD is equals to change in length of 1 plus 2 plus 3. Here I will find out change in length of first AB, that is delta L AB I will find out. Delta L AB is equals to PL by AE, that is the formula, and here P means load. If you see, this is the for part 1. Okay, we are finding for part 1. P load is 60 kilonewtons. Okay, as I have told you previously, we will always take load in newtons. Load I will take in newtons. So P value is 60 kilonewtons. So we need to take 60 into 10 cube, that is Newton. And L value here is 1.5 meters. Here length I will take in mm. That's why 1.5 meter I will 1.5 meter into 10 cube. That is I am taking length in mm divided by area. Area we have got here 490.6 mm square. So 490.6. Okay, area I will take in mm square. And E, Young's modulus. If you see Young's modulus, here 200 gigapascal given, but we want Young's modulus in megapascal we need to write, because all the units are Newton, mm. So Young's modulus we need to take in megapascal. That's why here Young's modulus I am taking, instead of 200 gigapascal I am taking 200 into 10 cube megapascal. Okay, for a load I have taken 60 into 10 cube. Length I have taken 1.5, that is meter to, I have changed it to mm into 10 cube, and area is 490 mm square, that is as it is I have written, and Young's modulus is 200 gigapascal, that I have changed to 200 into 10 cube megapascal. So if I calculate this, I will get 0.917 mm. This is delta L of AB. For only AB I have got this much, 0.917. Similarly, we need to find out delta L. Here I have find out delta L of AB. Now I will find out delta L of BC. Delta L of BC is equals to, here also same, PL by AE I will write, and if you see P, that is 70 kilonewton is acting, so 70 into 10 cube, because I want in Newton. In L is same 1.5 meters. So 1.5 into 10 cube, because I want length in mm. Area is, I have calculated here, 490.6 mm square is the area. Area is constant throughout the length. So 490.6 I am taking here. Okay. So area is 490.6 mm square, and E, Young's modulus, is 200 into 10 cube. I am taking Young's modulus in megapascal. So delta L of BC we will get 1.07 mm. Okay, after calculating in calculator you will get this value. Similarly, we need to find out delta L of CD. This is also PL by AE, and load of CD. CD, if you see here, load 50 kilonewton is acting. So 50 into 10 cube, because load we are taking in newtons. And length is same, 1.5. Length is same for all the three. Okay, 1.5, 1.5, 1.5. That's why length we are writing 1.5 meters. I am converting it to mm. 1.5 into 10 cube divided by area 490.6. Area is constant, and Young's modulus 200 gigapascal. I am writing in megapascal. 200 in 10 cube megapascal. If you calculate, we will get 0.764 mm. Okay, and here delta L of AB. AB is equals to delta, AD is equals to delta L of AB plus delta L of BC plus delta L of CD. Okay. So here we need to sum up all the things. That is delta L AD is equals to 0.917 mm plus 1.07 mm plus 0.764 mm. If you sum all this, we will get 2.751 mm. Okay, delta L of AD is 2.751 mm. Okay, here in this question they have asked to find change in length in the bar. Change in length in the bar, delta L is equals to 2.751 mm. This is the answer we have got. Hope you like this video. Thank you. Thanks for watching.